For the average rate of change, we're looking at this function, and I'll call this f of x, and it keeps on going in both directions. And what I'm going to do is find the average rate of change between 2 points, and I'll just pick 2 points on the graph. So let's take the point 1, 1 and the point 2, 4. If we want to find the average rate of change, that would be the same thing as finding the slope of the line that passes through those 2 points. The average rate of change, we can think of the slope formula. And remember, the formula for average rate of change is f of b minus f of a over b minus a. And that means the same thing as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If I label these points, I have 1, 1 and 2, 4. And then I can find the average rate of change just by subtracting the y's. 4 minus 1 over the x's, which is 2 minus 1. Doesn't matter which point you put first and which one second. And so then we have 3 over 1, which is 3. So if I draw a line through these 2 points, then we can see that the slope of that line is 3. If you wanted to see that on the graph, remember how the slope is rise over run, going straight up and then straight across. You can see that we're rising 3 units and running 1 unit. This is average rate of change. So the average rate of change is when you find the slope. And this leads to the derivative. Now this is the same graph as the previous one. I have f of x, and the equation of this graph is y is equal to x squared. Another way of writing the slope is thinking of it as the difference quotient. Do you remember how we had f of x plus h minus f of x all over h? Let's look at that for this problem here. So in the previous problem we just did, we found the average rate of change between 1, 1 and 2, 4. And we drew a line. Now, if we start off with x equal to 1, think of this as the x here. So this is the x is 1. And then going from 1 to 2, that's like the h. So for this problem, going from x from 1 to 2, this h here is 1 unit. When we're trying to find the derivative, what we're doing is we're taking the limit as h approaches 0 of all of this. As h gets smaller and smaller, it's getting smaller and smaller, so we're just going in this way here. This point here would get closer and closer, and you could find all these slopes of lines until we have a slope of a line that's really close to the slope of the tangent line. And the slope of the tangent line is the same as this limit. The limit is h approaches 0. If we wanted to find the slope of a tangent line of a graph, we can use this formula. And so that's what I'm going to do for this problem. And you can see I chose an equation that's very simple, f of x equals x squared. Let's find the derivative. Remember, the derivative is f prime of x. Using this form, I'm going to now use this equation. We have f prime of x is equal to the limit as h approaches 0, replacing the x with x plus h. So f of x plus h is x plus h squared minus f of x, which is x squared, all over h. Now we want to simplify the fraction. Do you see how we cannot plug in 0 for h yet? Because that would give us a 0 in the denominator. X squared plus 2xh plus h squared, if I multiply that out. You can write it out twice in FOIL and you'll get the same thing. Minus x squared all over h. Now do you see how the x squareds subtract out? Now I want to get it so that there's no h in the denominator. There's also an h we can factor out of the numerator. So we have 2x plus h left over if I factor out the h. Then divide out the h's. And now this is really nice because the fraction went away and we can plug in the 0 for h. We have 2x plus 0, which is 2x. What we just found is the derivative of f of x. This is 2x, and this is just a general form. So let's think about what that means. This describes the slope of a tangent line to the graph of x squared. And it depends on what x is for the slope. Let's do some examples. If we wanted to find f prime of 1, what we're doing is we're finding the slope of the tangent line at 1. If I plug in 1, we have 2 times 1, which is 2. So the slope of the line that I drew here, this is at x equals 1, the slope of that line is 2. If we find f prime of 0, so the derivative of f at 0, we're plugging in 0 for x. 2 times 0 is 0. Well, what we just found is the slope of the tangent line at x equals 0. Well, if I draw the tangent line, do you see how that has a slope of 0? It's because it's a horizontal line. Another one, if we find f prime of negative 1, I'm plugging in negative 1 for x, then we get negative 2. And what does that mean with the graph? Well, if we go to negative 1 for x, draw a tangent line, and you can see that the slope is negative, and it's actually negative 2. So when we're finding the derivative, we can find the slope of any tangent line just by plugging in whatever number you want for x to find the slope at that x value. To rehash what we just did, we found limits, and then we worked with limits at infinity and continuity, and then we looked at the average rate of change, and then that all culminated into being able to find the derivative. Now you can see that this problem here that we just did is actually pretty messy considering how simple the equation is, f of x equals x squared. So what we're going to do in chapter 4 is we're going to find the derivative in a much easier way using techniques that we're going to be given to find them. So you're not going to have to use this really long formula here.